Our next lesson is about applying exponent properties involving quotients. So when you divide powers with the same base, let me write this in expanded form. A to the fifth is A times A times A times A times A. A to the third is A times A times A. You can simplify by canceling out a pair from the numerator and the denominator. All that's left is A squared. So when you divide powers having the same base, you subtract the exponents. Like, let's see. A to the m divided by A to the n is A to the m minus n. So using that power, I can simplify this. I don't really want to write 8 times 8 times 8 times 8 times 8 10 times. That's only 8 over 8 to the fourth. I can cancel out 4 of them, and all I'm left with is 8 to the sixth. It's much easier to say 10 minus 4 is 6. Try these next 3 on your paper and press continue when you're ready to see the answers. If I'm going to subtract, I'm just going to keep the parentheses around the negative 3. 9 minus 3 is 6. You've canceled out 3 of the negative 3's on top. Here, 5 to the 4th times 5 to the 8th gives me 5 to the 12th. 5 to the 7th is on bottom. 5 to the 12th divided by 5 to the 7th. If I subtract, I'm saying 5 to whatever 12 minus 7 is, I'm saying 5 to the 5th. These all said to write your answer using exponents, so I'm not actually evaluating the answer. Here, if you have 1 over a number, so you have a fraction, times a whole number, it's the same thing as saying 1 over x to the 4th here, times that whole number over 1. This makes it a division problem. X to the 6th over x to the 4th, which just makes it x. There's a similar thing that happens with quotients. You've seen it when you've had to square a fraction. When you raise a quotient to a power, because here I'm doing a over b to the 4th, I have a over b times a over b times a over b times a over b. I'm really doing a times a times a times a to the 4th, over b times b times b times b. So if you're finding the power of a quotient, you find the power of the numerator and the power of the denominator and divide. So generically, if I change the exponent to be something that's also a variable, I'm doing a to the m over b to the m. Try these two. See how it goes. X over set y to the 7th, just to show you why that works again. Seven times. Now I've got my 7 times. There's 7 of them. So then it's just x to the 7th on top, y to the 7th on the bottom. Here, I'm squaring both parts. This one doesn't say to leave it with exponents, so I'm going to evaluate what I can. So this is saying negative 7 squared over x squared. And negative 7 times negative 7 is 49. This is 49 over x squared as a final answer. Here are some other examples I'd like you to try. If I'm raising this whole quotient to a power, that means I have 4x squared quantity, that whole quantity to the 3rd, over 5y to the 3rd. So now I have this whole thing to the 3rd means I have 4 to the 3rd times x squared to the third. On the bottom, I have 5 to the third times y to the third. It doesn't say to leave it with exponents, so I do have to find out what 4 to the third is. 4 times 4 is 16 times 4 is 64. X squared to the third, 2 times 3 is 6, so I've got x to the 6th. That's the numerator. 5 to the third is 5 times 5 times 5, that's 125. This is the best answer. Here, if we're raising this whole quotient to the 5th power, we're doing a squared to the 5th power over b to the 5th power. We're doing times 1 over 2a squared. A squared to the 5th power is a to the 10th. When you multiply a fraction by another fraction, you're just multiplying numerator times numerator. So you get a to the 10th on top. Denominator times denominator, we get 2a squared times b to the 5th. But I have two a's here, two parts with a. So since they're part of a quotient, I can subtract. I get a to the 8th over 2b to the 5th as my final answer.